Okay. Good evening, morning, afternoon, depending on what time you're watching this. In this video, we are going through the 2024 May-June Mathematics Paper 2. We're going to go through this paper from start to finish without leaving anything out. So, without wasting any of your time, let us begin with question number 1. Statistics. This is a statistics question. It says here, the number of pages in 10 A4 books and their corresponding weights in grams are given in the table below. It says the data is represented in a scatter plot. So it says here it's A4 books, so they have different pages, which is why the weight is going to differ. So a book with 85 pages going up until 160 pages, these are the different weights. And we can see that the number of pages, it's not in numerical order. You see it's going up, going down, going up, going down, etc. Hence why the weight here will also go up and go down. However, when the data is now in your table, your weight will be in numerical order from the smallest weight to the highest, from the least pages to the most pages. So 1.1 says we should determine the equation of least squares regression line. So before we go through these easy statistics question, in my opinion, what you're welcome to do is you're able to just skip through this video to the specific questions that we actually need assistance with, if these are some of the questions that you went through and they were not a big issue. But for the sake of this recording, we go through everything. So let's see here. It says here, with the equation of the least squares regression line, right? We let's see, we're going through May. It's so weird writing a heading while recording. You'd think to yourself, why didn't I just write it beforehand? But it's all good. Question number 1 says here, equation of the least squares regression line. You're looking at y is equal to a. Is it equal to a? Bro, y is equal to bx. It's a plus bx, ax plus b. Y is equal to ax plus b. This is how you know I haven't written a paper in a long time. I went through paper 1, yes, but obviously paper 2, I haven't done much in that region. So if you're going to work out the equation of the least squares regression line, you need to use your calculator. You need to input this data into your calculator. And fortunately, you don't have to put it in numerical order. So you're going to press mode, and then you're going to press 3 for stat, and then you're going to press number 2 for a plus bx. So you can see here, this is asking you to put in data for the x-axis, data for the y-axis. So you can see your number of pages first. So ideally, you can just put in all the x values first. So that's like 85 equal to 150, 100, 120. So what you could actually be doing for yourself is you can also be going through this paper, but then you can pace yourself, comparing yourself to this video. What I mean is you can start this exam, right? And then when I'm on question 1, you can also be on question number 1. And then you can try out the question. You can even mute the video if you want, so that you maybe don't hear anything. Or you could just pause it until you're done working out the question. And then when you're done working out the question, you can then mark using the video if you don't have the memo, you see. And then if your answer is correct, great. If it's not, then you can see where you went wrong. As of this recording, the official memo is not out. So may I please just disclose that if there are any small errors, I apologize, but we are all humans and that is inevitable, but we will definitely try to keep it to a minimum. Once you put everything in your calculator, you're going to press the on button, then you're going to press shift and then the number 1 button, stat, and then you're going to go to reg for least squares regression line. And then we need a and b, so you're going to get a first equal to, so this is worrisome because our a is a negative, whereas ideally, wait, I'm thinking, do I have to put the data in numerical order? Do I? In my mind I'm like, no we don't, but the funny thing is with statistics, we always usually use data in numerical order. So let's actually see what effect that will have on our answers. So without a numerical order, we're getting here, let's say here non-numerical. When I say numerical, I mean like from smallest to biggest. Well, let's not say numerical then. Let's say in ascending order or descending order, because numerical means numbers. Bruv, what are you saying, you know? So when it's not in ascending order, non-ascending, we have a as negative 43.72, right? And then our value of b, shift stat reg b, it's 2.36. So for the sake of us experimenting, let's also check what our value of r is for future reference. This is 0.97 if you round it off. Okay, so because of the way this data is inclined, you see it's almost like a positive graph. The value of a, you would also expect it to be a positive number. So let's put this data in numerical order, in ascending order. So let's clear everything. And then let's put the data in the calculator, but starting with the smallest number, ending with the biggest number. So 85 is the smallest number. The next number, that's the second smallest, is 90. And then from 90, we have 100. And then from 100 we have 105, yes, and then 115, definitely, 120, 135, 140, yes, 150, and then 160. So I think that may have been a catch, you know. So here this would be 180. This would be 200, yes. This here would be 170. This here would be 230. Here we would have 250. Here we would have 250 again, which is interesting. But okay. At 135 we have, yes, fine. This is 140. 140 we have 285. 150 we have 325, and then 160 we have 340. Okay, so this is now in ascending order. Let's see if that affects our answers. 85, 90, I'm putting in these numbers, see, 100, and then we have, what else do we have there? We then have 105, and we then have 115, 120, 135, 140, 150, 160. If you go all the way to the top, let's see, you're gonna have 165, 325, 200, 250, 180, 285. No, You see, I'm getting it. I put in the wrong data. Wow, that's very strange. 165 and then 180. I wasn't looking at the numbers that I wrote in pen. 180. Then we have 200. Yes, that's correct. Then I have 120. Wait, 200 and then 120. Bruv, are you serious? It's 170. So the crazy thing is, I think it's just like here also, where we have 250 for the heavier one, 250 for the lighter one also. So I guess that's normal for our data. So this is going to be 170 and then 230. So you see, you have to be careful. 250 and then 250 again, 285, 325, 340. There you go. Okay, so let's see. All this data, I press on, shift, stat, reg, moment of truth. Bam, it doesn't change your data. I guess we have both experimented. And you may be thinking to yourself, bro, how did you not know this? Well, this is not exactly something I did not know. But for the sake of us all being confident with our answers, I thought we should just do that also, you know? And I haven't gone through these papers in a long time. And I don't have a memo. So I do not want to mislead anyone, you know? So we double checked and we are all good. So we have A and we have B, which worked out to be 2.36. That's all nice and dandy, you see? Don't have to put the numbers in ascending order. They said here, draw the least squares regression line in the scatter plot. So if you're going to draw your least squares regression line, I'm thinking of this ruler that I put away not so long ago. And now I'm thinking to myself, dude, where is that ruler? I need it now. And I put it away. Why I did that, don't even know. Now watch me draw a line using a book. Wow. Or using a calculator. But it's all good. So if you're going to draw a line of the line of best fit, which we can refer to that if you're asking for the least squares regression line, it's basically the line of best fit. Normally what you want to do is you want to draw a line that almost like cuts your data in half. Like half of the data is going to be below the line, half of the data is going to be above the line. It doesn't have to be exactly half, but that's like the ideal, you know, way to do it. And you may also want your line to pass through one or two points. And a transparent ruler would have been best right now, but to try and now look for it, I may not find it right now. So let's just do this. So you see that line is going to pass through that point and that point. So let's do this. There's your least squares regression line. Okay, so you can see it almost cuts the data in half, but it's all good. Moving on, it says predict the weight of an A4 book that is 110 pages. So when they say predict, right, it's more of a way of you needing to use your graph. So with your graph, what you're seeing here is, you see, this is 100 and this is let's see, this is 0, 20 is over here, 40 is over there. So it looks like after every 4 pieces you have, so it's like 5, 5, 5, 5. Every jump is 5. This is 105, 110, 115, 120. So 110 is in the middle here. You see, so if you trace that 110 to your line, it's going to end up over here somewhere. If you trace that to your weight, it's going to end up here somewhere, you see. Now if you look at your data from 0 to 50, this is like 1, 2, 3, 4, wait, let's see, 1, 2, 3, 4, 5. So each marker here is representing 10. You see 10, 20, 30, 40, 50. So from here, this is 200 plus 10, that's 210. So the weight is going to be 210 grams. You see, so when they say predict, try not to use your equation on your answer sheet. Like you can maybe just put the equation in your calculator only. Or then you can use your equation, right? And since they gave you the number of pages, you can put 110 in the equation. Only in your calculator, don't put it on your answer sheet. You see, 43.72. We have 110 plus 2.36. Whoa, something is not adding up here. What? Bruv. Yeah. Something is not adding up. Because why am I getting such a big number? 110 pages. Yeah, this doesn't make any sense. This doesn't make any sense. It also goes back to having this answer as a negative. Like it's such a concerning answer. Let's see. Shift, stat. Let's see our data. Okay. My data looks fine. Yeah, there's nothing wrong with our data. Shift, stat, reg, A. Okay. Shift, stat, reg, B. Yeah, these are the answers we're getting. So this is quite disturbing, to be honest. Predict the weight of the book. That is 110 pages. 110 pages, we predicted the weight. So if you're going to use the equation to try and estimate this, wow, it's not working out. And the equation in itself, it's just very, very strange. So I understand if you're also a bit at edge, but that's what we have for now. 1.4 says calculate the weight. Calculate the weight increase between book 110, between a book with 110 pages and a book with 130 pages. So a book with 130 pages, if you were to estimate that, a book with 130 pages, that's like here, right? So if you trace that to your line, that's like somewhere over there. If you trace that to your weight, that's about 260. So it's gonna be 260 minus 210 equals 50 grams difference. Okay, there we go. It's just the 50 grams difference. So what else do we have here? We have question number 1 done. So we can now move on to question number 2. Question number 1, not so bad. But I understand how this can be very concerning to a certain extent, you know? Because it's a negative value, but in our line here, it's a graph that has positive, it's a positive inclination. Question number 2. This is what question number 2 looks like. It says here 50 athletes need to access suitable training facilities. The table below shows the difference in kilometers that they need to travel to obtain access to suitable training facilities. So 3 athletes have to travel between 0 to 5 kilometers, and then all the way to 3 athletes needing to travel between 25 to 30 kilometers. 2.1 says it says complete the cumulative frequency column provided in the table in the answer book. Well, we don't have an answer book, but we'll be okay. Question 2. let's see what we got here. Okay. Question number 2. With your cumulative frequency column, let's just put here 2.1 cumulative frequency. This is cumulative frequency, you see? So, well, let's actually just do it here. And then we can just put it on the answer sheet or on this paper afterwards. So when you draw your cumulative, when you write down, when you eventually get your cumulative frequency, this is how you do it. You'll be adding up these numbers one by one. So with the first one, there's nothing to add it to. So it's just 3. Add a 7, you get 10. Add a 20, you get 30. Add 12, you have 42. Add 5, you have 47. Add 3, you have 50. That's your cumulative frequency column. See, 3, 10, 30, 42, 47, 50. Not bad at all. Question number 2. We went through 2.1 already. Now with 2.2, right? It says here on the grid provided in the answer book, draw a cumulative frequency graph, which is the archive to represent the data. So questions like 1.2 and 2.2, these are the kinds of questions that should just be free, you know, because there's really no reason to be getting such questions wrong in this day and age. So this is what you're going to have. You have an x-axis and a y-axis. Along the x-axis, you're going to put your distances. You see, it's incrementing in 5s. So you can have 0 here. Let's try and put it like that. 5, 10, 15, 20, 25, 30, right? 5, 10, 15, 20, 25, 30. And then on the cumulative frequency side, it's from 3 all the way to 50. So you can also go in 5s. That could also work. 5, 10, 15, 20, 25, 30, 35. Oh no. 40, 45, and then 50. Okay. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Don't mind the way I wrote it. I'm trying not to spend too much time on this kind of a question because it's actually very straightforward. So what you do is on the 5, 10, 15, 20, 25, and 30, that's how you're going to make your points, you see. For 5, you put a marker at 3. So 3, it's like somewhere there. For 10, it's at 10. So that's like somewhere there. For 15, it's at 30. That's quite interesting. 15, it's at 30, which is like somewhere up there. For 20, it's at 42. 42 is like 40 here. 42 is just above. 25 is at 47. 25 goes all the way to 47. And then 30 goes way to 50. 30 goes to 50, right? There you go. So your archive will look something like this. You can plant it at 0 there. There you go. Easy marks. Easy 3 marks. So that's 5 plus 3 marks. 2 plus 3 marks, that's 5 marks easy. Now 2.3 is asking you to work out the interquarter range of the data above. So interquarter range, your formula is just your minimum, your maximum minus your minimum. That's no. Interquarter range is Q3 minus Q1. What I was talking about is the range. Range is maximum minus minimum. But then the interquarter range is Q3 minus Q1. So 2.3 IQR interquarter range is Q3 minus Q1. So obviously you may be asking, fine, how do you get Q1? How'd you get Q3? So using your archive, this is how you do it. You're going to need to use your cumulative frequency side of things. So on your cumulative frequency side, remember Q1 represents where a quarter of your data is. Q3 represents where 3/4 of your data is. So what you want to do first is you want to work out the positions of Q1 and Q3. So let's put here position Q1 will be a quarter, right? Multiplied by n plus 1. This is how you work out the position of Q1. So let's see, a quarter here. N represents all the data that you have. You have 50 people. Plus 1 here. Let's see what this is going to give us in the calculator. A quarter. This is a formula, so okay. In the previous question, we were using the table, so let's clear the calculator. You see. So let's put this now. A quarter multiplied by n plus 1. This is giving you 12.75. So what that means is in position 12.75, that's where your Q1 will be. So 10 is here, 11, 12.75, you're gonna have somewhere over there. And my data is not, if I had proper grid paper, it would be more accurate, right? So just bear with me. That's where Q1, that's the position of Q1. So you would trace this to your data, and then you would trace it down. You see, so Q1 is between 10 and 15. So we can maybe just coincidentally here, this is also going to be around 12.75, coincidentally. And then Q3, position of Q3 is going to be a quarter there. Q3 is 3/4. 3/4 n plus 1. This is giving you 3/4 n plus 1. That's giving you 38.25. So what you do is you're gonna go all the way to 38. So 30, this is where 35 is. So 36, 37, 38 will be somewhere there. Then you trace that to your archive. Trace it down here. So this is falling somewhere around 23. You see. So remember, this is representing the kilometers traveled. This is representing the athletes, the number of athletes. So when they say the interquarter range for the data above, you're going to take Q3 minus Q1. Interquarter range, you're going to take Q3. Wait, where did you Q3, this would be around 20. Let's take 23. So let's say 23 minus, here we said this would be almost in the middle of 10 and 15, you see, but let's just maybe round it up to 13. So this is going to give us 10. The interquarter range of the data is 10. So remember, you may have a different answer, or the memo may have a different answer, most probably because the archive will be more to scale, you know, with grid paper and everything. So the purpose of this tutorial is to show you how to get the position of these values so that you can then work out the actual number they're asking for. The formulas just help you to get the positions. Once you get the positions, you trace it to your archive. Trace it to your archive. So you can do that on proper grid paper, and then you'll have more accurate answers here. You see. So let me write down the 23 here, and the 13 here to show where we got it from. 2.4 says Question number 1. The families of 4 athletes above who stay between 15 to 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the facility. In which interval will the number of athletes increase? Well, if they move 10 kilometers closer, 4 of them, right? So it means from the 12 here, this would decrease, from the 15 to 20, this would decrease by 4. And then it means that the 5 to 10 will increase by 4. So the interval that will, let's see, actually, that's actually a good question. Here we have to be careful because it says these people between 15 to 20, they moved 10 kilometers closer. So we have to remove 10 from the 15, 10 from the 20. So ideally that's going to be 5 to 10. Yes, that one is not even a difficult question. 2.4, that's 5 to 10. Okay, so 2.5 says what? What do we have to do with 2.5? 2.5 says the following. It says here, calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Okay, so the mean distance, this is not too difficult because what will happen is that this here, if you remove 4 here, this becomes 8. If you increase 4 here, this becomes 11. Okay, so they just mean calculate the mean if this is what the data looks like. So calculating the mean, fortunately, you can actually just use your calculator. It's very, very simple. So let's just make sure the calculator is cleared up. Shift clear. Okay. So in the calculator, right, you're going to put in all your data and then you're going to get the mean. So you may be asking yourself, okay, fine. If we're going to use the calculator to get the mean, how do we make sure we get all 3 marks? Well, that's where statistics is a bit of a friend, because your memos will easily give you all 3 marks for just putting the answer. But you can obviously write out whatever you feel you need to write out to make yourself feel better. But let's just do the calculator work for this question, because fortunately statistics, you're allowed to use your calculator. So in your calculator, the first thing you want to do is you want to press mode, right? You want to put your calculator into frequency mode. So let's do shift mode. Then you're gonna scroll down. Let me try and find it here. Frequency mode. Come on, bruv. Come on. I feel like maybe I should pause and then look for the frequency item that I'm thinking of. Yeah, because I need to put it into frequency shift mode. 4 stat. There we go. So you're going to press shift and then mode, right? You scroll down, you press 4 for stat. Start again in case you're not seeing that. Shift mode, and then you're going to scroll down, you're going to choose stat. So you want to switch on your frequency, you see. Okay, so when you switch on your frequency, you're going to press 1. So now that your frequency is on, right, you want to put data into your calculator. The data that you're going to be putting into your calculator, it is firstly the midpoints of these numbers, right? Let's put here midpoint. This entire data, you're going to put the midpoints between 0 and 5. The middle is 2.5. Between 5 and 10, the middle is, so all you do to find the middle of 10, 5, 10, all these numbers, you just add them together, divide by 2. 10, 5 plus 10, divided by 2, That's 7.5, you see. And then between 10 and 15, your middle there is going to be 12.5. Is it really? Are you sure? Yes, I'm sure. Wait, no? Yes, of course. Why am I overthinking such easy things? Between 15 and 20, it's going to be 17.5. So you see, we can just be adding 5 all the time. 17 plus the 5, it's 22.5 here, and then plus 5 again, it's going to be 27.5. So all you do now is, since you see your calculator is already in frequency mode, your data, you're going to put it as follows. But what am I saying? Yeah, so we have our midpoint, and we have our number of athletes, and we also have the frequency column. So all we need is the midpoint with the number of athletes. So what you do now is, in your calculator, you're going to press mode, and then you're going to press stat, and then you're going to choose var. You see, so what you can already see there is that your calculator has your value of x, which will be your midpoints, and then frequency will be this column, you see. So for your 3 marks, you can be communicating with your examiner. You can easily say something like calculator in frequency mode. That's what you did first, right? And then midpoints for distances traveled, you have 2.5, you have 7.5, 12.5, 17.5, 22.5, and then lastly you have 27.5. You see, the number of athletes you're already given. So anyways, let's just put that in the calculator. So for x, 2.5 equals 7.5, 12.5, 17.5, 22.5, 27.5. So me doing this, it's just a matter of communicating with the examiner. So it's not anything fancy, anything crazy. It's just you trying to communicate with your examiner so that you get all your marks, you see. So remember, we have to use the 3, 11, and the 8 also, because we are taking 4 from here, putting the 4 over there. See, so we have the first number there is a 3, then you have 11, then you have 20, then you have 8, then you have 5, then you have 3. Okay, perfect. So we're putting all this data. Okay, now fortunately, what you do know is that your mean as a formula is just going to be 2.5 times the 3, you add this times this, you add this times this, going on and on. So as a calculation, you can just say 2.5 times 3, you add 7.5 times 11, you add 12.5 times 30. Yeah, I just thought let's just write it out just to ensure those 3 marks. 17.5 times 40. Whoa. I used the wrong number here. It's supposed to be 20. Because we're using this 20. This times 8. I was about to put the 42. And then 22.5 times 5. So you see, the reason why we're putting it into our calculator is because it saves us the trouble of doing this manually, you see, because this is what your mean is. You're going to add everything up, right? And then when you're done, you're going to divide it by 50, you see, but your calculator is already going to do all that for you. So here you're going to press shift stat and then var, you see, and then you want your mean, so it means number 2. There you go, 13.5. So your mean here is 13.5. So that's the mean distance. So it's going to be 13.5 kilometers since we're talking about distance. See, so that's that for a question like this. Gonna get 11 marks. I feel like we've spent way too much time on statistics. Question 1 and question 2 should not have taken as long as it did. Not in a perfect world, or rather, not, yeah, it took way too long. But that's what we have. So let's move on to question number 3, and we can at least start with the more difficult questions. Question number 3. Let's see what question number 3 says. So before we even dive into question number 3, right? The first 2 questions were on statistics. Now, I know statistics is simple, but for those that still find statistics a bit confusing and a bit difficult, my suggestion is that you sign up for the statistics course on our website, Bright. courses.brightyoungbrains.co.za. You see, this is where you're going to get the knowledge that you need for the courses that the knowledge that you need for the topics in your maths syllabus. So question 3 here says that you have a diagram. This diagram looks very, 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 very familiar. By 2024, you definitely would think that they have recycled so many questions. It's just crazy. Like, there's no new questions really. There's rarely any new questions these days when it comes to maths exams and all that. Like, honestly, there really isn't. It's so difficult to find something new. But it's okay. In the diagram here, A is over there, B is open, C is also open. These are vertices of a triangle. AB is produced to S. Yes. And then it says here D and F are the X and Y intercepts of AC, respectively. F is the midpoint of AC. Okay, that's very useful information, because if you did not read the description, then this would be very, very difficult, because unless they tell you this kind of information, you cannot guess or assume it. Then they say it here, it is the midpoint of AC and the angle of inclination of AC is alpha. Then it says the equation of AB is given by kx plus 3. Okay, that's fine. That's all right. And then it says the equation of AC is given by y is equal to 2x minus 2. Okay. This question is out of 22 marks. I don't think it's going to be a problem at all. I don't think by any stretch of the imagination, this question is going to be difficult. I just don't see it. But anyways, 3.1 says the following: show that k is equal to a third, and it's a single mark question. So we can already see why I said what I said. So this is y is equal to, y is equal to what? Y is equal to kx plus 3. Well, if you're going to get what am I trying to say here? If you're going to get the value of k, simply put, you have a point that the graph passes through here, right? Like, you have a point that the graph passes through, the graph of A, B. It passes through coordinate 3. So you can just put in a coordinate that the graph passes through to get k. Y is a 4, x is a 3. This is 3k plus 3 over the 4 here. 4 minus 3 because the 3 will go over, right? 4 minus 3 is going to be a 1. Divide by 3 on both sides here. K is equal to a third. There you go. Easy marks. You see. So them asking us to work out the value of K is really not been an issue, as it shouldn't. 3.2, my handwriting, I still wonder why it's this bad, eh? Will it ever improve? Maybe it's the kind of pens I use. Like, I'm not blaming the pens. Okay, it says you calculate the coordinates of B, which is the x-intercept of A, S. Very easy marks again. Getting a y-intercept, you're going to make, an x-intercept, you're going to make y as 0. So 0 is equal to a third x plus 3. This is giving you -3 on this side. And then if you divide -3 by a third, you see, -3 divided by a third. Whoa, let's clear the calculator from the previous questions. So -3 divided by a third, you're going to have your -9. -3 divided by a third, x is equal to -9, which is okay. So they say the coordinates of B though, you see. So B, gonna have to put it as a coordinate. You see. Otherwise you will just get 1 mark if you just wrote x is equal to -3. 3.3, let's see what we got here. 3.3 says the following. Calculate the coordinates of C, right? So C is on the other side of AC, but we don't have F. We can easily get F because we have a point. We have an equation of the line AC. So if we get F, which is easy, we can then use it to get C. That's why this is a 4-mark question, because it's just multiple steps, but nothing difficult. So here we know that y is equal to 2x minus 2. What we do know here is that the y-intercept is at F, right? So we can make x as 0 here. So here we can say y is equal to 2, 0 minus 2. Why I even calculated that in the using the formula is weird, because you can already see this, the y-intercept is -2, but it's all good. So here we can put here 0, -2. Fine. So we have a point that the line starts. This is the middle, this is the other side. So when you use your midpoint formula, remember what you know is that with your midpoint formula, right, you have x1 plus x2 over 2. And then you have y1 plus y2 over 2. There you go. So with this being said, you can think to yourself that this whole x value is equal to a 0, you see. 0 is equal to this x value here, x1 plus x2 over 2. And the -2 is equal to this entire y value here, y1 plus y2, over 2. Okay, so we can now put in x1 and y1, because if you think of your value of a, that's 3 and 4. Oh man, my handwriting is so good. Not. So x1 will be a 3, right? So you can put your 0 is equal to 3 plus x2 over 2. The other way, and here you can put -2 is equal to 4 plus y2 over 2. So this side you can multiply by 2 on both sides. This is still going to be a 0. x2 is equal to -3, which makes sense because you see this is on the left side of your, it's on the left side of your what? It's on the left side of your x-axis, yes. So for the y, you do the same thing, times 2 on the left and the right. You're gonna get the 4 plus y2. This goes to that, so that's -8. Therefore here -3 and -8. And then you get here -3 coordinate -8. So with 3.3, you're done. 3.4 on the other hand, what do we have here? 3.4 on the other hand, 3.4. It says here, right? Determine the equation of the line parallel to BC. So you want to determine the equation of the line parallel to BC. Yes, and passing through S. Okay, so it's gonna be like there. It's a line parallel to BC. It passes through S, so that's a line that looks something like this. You see, these are parallel. So even when you draw it out, it makes life very easy to see. So fine, it's parallel to S. Wait, it passes through S, which is this coordinate. They gave you the coordinate of S just like that. Okay, well, even if they were to ask it, they have to have given you more information. So we need to, it says determine the equation of the line parallel to BC and passing through S, which is this coordinate. Write your answer in this format. I am wondering why this is a 5-mark question. Like genuinely wondering why that's a 5-mark question. Yeah, I really am wondering. But maybe, obviously, it looks like they want you to get the gradient first. Getting the gradient, you may need to use B. But then to use, the line BC. To use the line BC, it's not an issue. Reason is, the coordinate of B, if you think of the previous question here when we had to work out B, we got the x value here to be negative, was it -9? Yeah, so -9 and 0. So this is a very easy question. I am really trying to figure out why they made it a 5-mark question. But we're not going to complain for getting marks, right? So it's them being generous, I guess. So the gradient, we know it's y2 minus y1 over x2 minus x1. So what we know about the gradient is that the gradient of BC is going to be the same as the gradient of this line. So what we know is y2, you can use anything. Let's take -8 minus the 0, -8 minus the 0, -3 minus -9. So -3 minus -9, that would be a plus. These are the kinds of questions where I love using the calculator because they're just so easy, you know, and the calculator makes you feel better even. Makes you feel better for not getting these questions wrong just because you made a silly mistake. So use your calculator whenever you can. There is no shame in using the calculator. This whole thing of mental math, blah blah blah, I mean, come on, you're not in grade 5, so just use your calculator. Oh, not done. We've gotten a gradient, right? The gradient of this line is the gradient of this line. So what we now know is that you can say y minus y1, and then here m, and then x minus x1. So the gradient of this line we have, the gradient of our line we have, it's just -4/3. And then the x value that we have is -15, so this would be a plus 15. Here we have -2, so this would be a plus 2. So if you multiply inside -4/3 with x here, this multiplied by the 15, right? Times the 15, you're gonna have -20. So you have y plus 2 here. And then that 2 goes to the other side, so it will be negative also. So this would be this. -22 minus 2, -20 minus 2, that's -22. So if you look at it, the way this line looks, yes, somewhere down there you would have negative 22. So for 5 marks, I guess these guys were just being very generous. Like, what a wow. But it's fine. 3.5 says we need to calculate the size of BC. So calculating the size of BC, what do we have there? No, the size of BAC. Goodness, BAC. So that's this angle here, right? So getting that angle, to be honest, it doesn't seem like a difficult question. But because they have given this angle as an unknown and they specifically mentioned it, you would want to work this out first. May help you. It probably it looks like it may help, you see, because the two things I'm already thinking of here is exterior angle of a triangle, you see, because this alpha here is the exterior angle of A and the B here, you see. So what you know is that alpha is equal to this angle plus that angle put together, because of the exterior angle of a triangle is equal to the sum of the opposite interior angles. That's a law. So you already know that all you have to do is to get alpha, get B. You can eventually get A also. So to get B, fortunately, you can use your angle of inclination formula to get this angle here. To get this angle, this part of D here, you can also use the angle of inclination formula. Very easy, 5 marks again, like wow. So here you can say M is equal to T alpha. So the gradient of AC, right, is what we're going to use to get alpha. So the gradient is just positive 2. So you have 2 here is equal to 10 alpha. So you have here shift 10 equal to alpha. Shift 10. Where's 10 here? Shift 10 is equal to alpha. That's going to be 63.43. Perfect. Now, that's quite straightforward. For AB, the line, the gradient of AB, we also have it, you see. So let's label this ABD. So M is equal to 10 A, B, D, or let's just say M2, you know, so that we don't have contradicting statements. So we have a third here, 10, oh no, how do you mess up writing the word 10? I put A under, oh goodness, yeah, it's rough. So here we have shift 10 is equal to this angle. So here, therefore, ABD is equal to what? Calculator, show us the way. So we have a third here. Close that just for the vibes. 18.43. So that's very comforting, as you can see. So here, to end it off, you can then say alpha is equal to ABD, right, plus angle BAC. That's what alpha is. Alpha is equal to this angle here, ABD, which is this small part here, plus that part over there, which is BAC as they labeled it. So this plus this, we know it's equal to alpha. You can even put in a reason, because you can. Exterior angle of a triangle. There you go. So here you can say, therefore, you're gonna have 63 here, 0.43 is equal to, what is ABD? ABD is 18.43 plus BAC is BAC, what is BAC? That's what we're looking for. BAC. So let's see, 63.43 minus 18.43. This is 45. So this goes to the other side. You can have 45. That's what BAC is. Very, very easy. 5 marks in my very humble, honest opinion. Very, very easy paper, this. There's really nothing that has been an issue yet. But we're on at question 3, so... But I'm hopeful. I am hopeful. Moving on. It says here, it is further given that the length AC is 6 square root of 5. So that's the distance. Okay? Calculate the value of this expression, another 5 marks. So I want you to get the area of ABD. So ABD, very easy to get, over ASC. ASC. Okay. So the other triangle is gonna look like this, right? Well, so fortunately, you don't have to worry too much about this kind of question, because if you think of the two triangles, right, you just have to get an area for this triangle, get an area of this triangle, and then just put them in this expression and then simplify. So to start off, right, the area of triangle ABD, right, that one is the easiest one, ABD, because the only thing you need to recognize is that the way your triangle is, it easily allows you to use half base times height to work it out, because this is your base and then this will be your perpendicular height. You see, now you already know that this is a 4, so the distance there is a 4, because from the x-axis going upwards, that's a 4. So you already know that your height is a 4. Your base, you can easily get a y, you can easily get the x value for d, because from B here up until there, that's 9 places. So from here to there, you can just get the distance by getting the x intercept of the line AC. So let's start there. Getting the x intercept, you have to make y 0. So y is 0. Then you have 2x minus 2. The 2 goes to the other side. Divide by 2 on both sides. X is a 1. So this is a positive 1. You see, meaning that the distance here is a 1 plus the 9 units. So 9 units plus 1, that's 10. There you go. So it means that your area here, therefore area of triangle ABD is equal to a half. You can even write it as a formula first if you want, because you can do that. But now height, let's just say height. Let's just put h. Okay, so this is gonna give you a half times the base times the height, which is a 20 units squared if you want. You can write it like that, it's up to you. So that's the first part. The second triangle, yeah, we really shouldn't have an issue with that one also. However, there's one thing about this triangle that I am thinking to myself. One thing I'm thinking is, if you're going to get the area of triangle ASC, funny enough, you need to ask yourself, why do they give you AC in the first place? You see, AC is the distance. So because they've given me the distance of AC and I have the coordinates of AS, the one thing I'm already thinking of here is I have the coordinates of, I can get the distance of AS. This distance is already given, which is a nice hint, because we could have easily worked it out. And we have that angle. So remember, anytime you have an angle that is in between two lines, you can easily get the area of that triangle using the area rule. You see, so the shape here looks like this. You see, So you have C here, you have A here, you have S here. So fortunately this is 6 square root of 5, right? And then the angle here, the angle in there, you worked it out to be 45 degrees. So the distance AS, you can easily work it out. AS using the distance formula. You don't need to be too fancy about it, but it's okay. Let's just put in the formula. x1 minus x2 squared, y1 minus y2 squared. So normally, these two, if you swapped them around, these two you just need to swap them around, and then the entire bracket you can also swap it with the entire bracket. It's up to you, but for now it's fine. So x1 we can make that negative 15, so negative 15 minus the 3, and then we have negative 2 minus the 4 squared. And then we're gonna have here negative 18 squared plus negative 6 squared. Okay, so let's just get the distance of AS. Square root, I'm just putting this in the calculator because I'm trying not to leave anything out. I'm just writing everything. So this is 6 square root of 10. Okay, so we have 6 square root of 10. Now our question is just ripe. It is just ripe. We have zero reason to get it wrong. So here we can then say our area, which we have worked so hard for, the area of triangle ASC. There we go. It's going to be equal to a half multiplied by AS multiplied by AC, and then multiplied by sine the angle SAC. There you go. Simple area rule. So AS here we have 6 square root of 10, 6 square root of 5. Our angle is 45 here. There you go. Put that in the calculator. The reason why they made this a 5-mark question is because there's just a lot of writing. So I think we can also conclude that 5-mark questions and all that, right? It's not because they are difficult questions. It's usually just because they want you to have multiple steps. Now in maths, if you can get used to writing out multiple steps for your answer, it makes life very easy for you, you see. So it means that this expression now that they wanted us to get, right? You can say here, therefore, area of triangle ABD, if you put it over the area of triangle ASC, this will easily give you, we have 20, right, over 90. See, the simplest form is just 2 over 9. Very, very straightforward question here. Question number 3, I think we took a bit of time, but while explaining it and while also going through it, yeah, it did take some time, but it wasn't a difficult question at all. That's one thing I think we can all honestly agree on. Question 3 was not hard. So we worked on it. Now we're gonna move on to question number 4. So with these kinds of questions, right, you have to remember that this is where you are going to learn to master all your topics. And yes, I will plug these online courses until the end of days, because honestly, it's your gateway to better maths marks. Don't say I never told you. So let's move on to question number 4. Okay, here we are, flipping the page, going on to the next question. So with question number 4, what we need to remember is the following. Now you may be asking, why is this thing labeled as confidential? That's a good question. Because this is a paper that has already been written. But I guess this may have been a copy that was out there before the day. Let me drop that way of talking. Question number 4 says, in the diagram, right? We have this. We have the circle centered at C. Okay, that's fine. And then what else? The circle centered at C is drawn. Okay, very nice. And it says A. We have A here. We have B there. These are points on the circle. And then it says here E is the midpoint of A, B. Can easily get that if we need it. 4.1 says calculate the coordinates of E, the midpoint of AB. Wow. It's okay. These questions are very doable. It's very nice. If I was writing this exam, I would be very happy. I'd be very, very happy. It's just funny how I'm at the point where if I see an easy question, it's almost annoying. It's like, really? How dare you? It's just so funny, but it's fine. Let's go through this question. Getting the midpoint, we already know what the midpoint formula says. Ugh, what am I doing, bro? X1. Oh, wow. Am I really? Let's just open a new page. Like, let's just do it. Because at this point, I am just wondering, why do I have to write so bad, you know? But maybe it's because of the pen or the book, or because as I'm thinking, my thinking and my writing, they're just so different. I write a bit slower than the way I think, but it's fine. So we're gonna make this x1 5. Okay, well, let's try. I always try to start with the negative numbers. Negative 3 plus 5, because it just makes life a bit easier. And then here, negative 3 plus 1. So this is giving us, clearing this out, because somebody had made a mistake. That somebody is me. So we have M now. 4.2 is asking for the length of the line AB. That's very easy, so we shouldn't get that wrong at all. Let's see. AB can just use the distance formula, x2 minus x1 squared, y2 minus y1 squared. And then we have here, can just put in the numbers. We can just put the, let's start with negatives, right? Negative 3 plus 5, negative 3 plus 1. What do we get there? Square root, negative 3 plus 5 squared, negative 3 plus 1 squared. That's 2 square root of 2. Perfect. Does that look perfect? Yes, it is perfect. But no, it doesn't look perfect. Because it's supposed to be a minus, bruh. But, wow. This is supposed to be a minus. Negative 3 minus 5. Negative 3 minus 1. Oh, goodness. There you go. That's your answer if you put it into the calculator. Minus over there. So yeah, I can imagine in an exam having to have been messy like this. You don't want to then let it pull you down too much, you know. Just keep writing. Don't slow down too much because of fixing too many errors. So 4.3 is asking us to determine the equation of the perpendicular bisector of AB. Okay, in the form y is equal to mx plus c. So don't mind me having to have put this here. This was actually from the previous question from the previous version that I did things wrong. So the perpendicular bisector will be like somewhere here. It will not pass through the origin, I don't think so. But anyways, with the perpendicular bisector of AB, it's a line passing through AB, passes through the middle of AB, and it passing through the middle of AB, this is the midpoint, so I should change this to E, because I labeled it M because of midpoint, but we were working on E here. So to get the equation of a straight line is just mx plus c, and getting the gradient of a perpendicular bisector, you can use the gradient of AB, and then you use the formula m1 times m2 is equal to -1. So getting the gradient of AB first, you can say here -3 minus 1, and then -3 here, minus 5. This is a half if you're simplified. So when you then do this, the new gradient is going to be positive, is going to be -2. That's the gradient of the perpendicular bisector. You see, if you put it into this formula, because if you put it into this formula without leaving anything out, you would have a half multiplied by m2 equal to -1. And then when you say -1 divided by half, this side divided by half, you would have m2 is equal to, I'm trying to write it down here. Oh no, come on my guy, write meter. I always ask people to write meter, but when I write, oh no, it's a mess. That's how you get this -2 gradient here. So here, now that you have the gradient, you can say y minus y1, x minus x1. The gradient here is -2. The x value that you can use is the x value of E, because the perpendicular bisector will pass through there. Then here you have -2x plus 2. Then you have -2x, 2 minus 1 is 1. There you go. There you go. So that's the equation of the perpendicular bisector. Very easy. Very, very easy. Not a difficult question at all. 4.4 says, show that P is equal to -3. P is the center, is the y value of the center. Now remember, your perpendicular bisector will pass through the center, because remember, a line from the center, if it cuts this in half, it means that it cuts it at an angle of 90 degrees. So meaning, since we already have a line that is cutting this chord in half and at an angle of 90 degrees, since we already have that, it means that that same line will have to pass through the center. So that's the equation here, you see. So to get the y value here, you can just throw in the x value over there. 2 plus 1, -4. There you go. Very easy 1 mark question there. 4.5, on the other hand, it's a 4 mark question. And we don't expect any resistance there, because this paper is proving to be horribly simple. Show by calculation that the equation of the circle is given by this equation for 4 marks. So if you're going to end up here, right, you're not going to just end up here. No, this is the easier version actually, because the standard form, you'd have to complete the square and all that, but it's all good. So if you're gonna get the equation of the circle, you are better off starting with this version: x minus a squared y minus b squared equal to r squared. So we can get this, the center we already have, right? AB is just given by 1, -1. So we have A and B. The radius, we can easily work it out. We can just get the distance of BC. Okay, so distance of BC, distance formula, x2 minus x1 squared, y2 minus y1 squared. So we can say here -3 minus 2 and then -3 minus -3, so that would be a plus because the p is a -3. And then this is something we can just put in the calculator altogether. I don't know why I put the square root symbol there, but whoopsie. -3 minus 2 squared. Then you're gonna have the -3 plus 3 squared. Ooh, syntax error. Why? That's a good question. Try that again. Brackets. -3 minus 2, the whole thing squared, plus -3 plus 3 squared. 5. So this would be 25, and the square root of 25 is a 5. This is not to say you have to work out what's under the square root first and then get the final answer. No, I just put the 25 there because I had written square root first. Out of impulse, just did that. So we have the radius, we have A and B, so we can just throw it in there and simplify. So here we have therefore x minus 1 squared, y minus -1, that's y plus 1. So this, if you FOIL it out, x times x is x squared minus x plus 1. This one, if you FOIL it out, y times y is y squared plus y plus 1. Okay, so then if you simplify here, what are you getting? This is a 5. I'm not getting the same thing. Yo, bro. That's because I'm using the wrong numbers. Man. I'm using 1 and -1 when it's supposed to be 2 and 3. 2 and -3. Bruh, come on. It's supposed to be 2 and negative. Yeah, I apologize. My mind seems to be very distracted at this very moment. That's why I keep making these silly mistakes. Supposed to be 2, this is supposed to be -3. +3, my guy. So x times x would be x times -2 would be, let's just redo that. X minus 2, x minus 2, y plus 3, y plus 3. So x times x is x squared minus 2x plus 4, y squared plus 3y plus 3y plus 9. Yes. Is it a plus or a negative? It is because I'm seeing a -12 here. Oh, the 25 is going to help. So if you put everything on one side now, you're getting here, what are you getting here? X squared plus y squared. That's -4y, 4x. And then plus 6y. 9 plus 4 is 13, right? So 25 minus the 13, or rather the 13 here, right? If you minus the 25 there, it's going to be -12. There you go. That's going to give you your 4 marks. Yeah, excuse the silly mistakes. I apologize. As I'm sitting here, I can literally feel myself thinking of other things as I'm writing this paper. And it's very destructive, as you can see. I know exactly what I'm thinking of, and I'm thinking of it while I'm doing this paper, and it's causing me to do all these silly mistakes. So the reason why I may not cut this out when editing is because it gives me an opportunity to also just show that if you're distracted when you're going through your exams, you will make mistakes. And sometimes you may not spot those mistakes. But it's all good. Let's carry on. Question number 5. So, let's see what we have here. We have, what do we have in question number 5? Watch me fix this thing as I get distracted. Question number 5 says the following, right? It says we have P, which is equal to sine 40. Sine 40 is equal to P. Write each of the following in terms of P. So as of this recording, I actually haven't done 4.6. I'll go back to it. The idea behind questions like 4.6 is that in an exam, when you bump into them, do not attempt until you're done with the whole paper, because this will take a lot of your time. 5.1 says we need to work out sine 22 after having to have been given this information. So this information, the first thing that we always do, sine 40, this is got to P, try to put it over 1, because what you will then be able to do is to draw some form of a triangle. You can label this 40, this will automatically be 50, and then this will be opposite of hypotenuse. So opposite is P, hypotenuse is 1. So to get this missing side, you can just use Pythagoras, because you have 1 squared is equal to P squared plus this is along the x-axis, I can say x squared. This will give you 1 minus P squared, x squared. Square root both sides. You have x is equal to square root of 1 minus P squared. There you go. So you have 1 minus P squared here. And then you have 5 we're not done, right? So sine 220, you have to break that down, you know. So let's break it down into sine 180 plus 40. Now if you're using your CAST diagram, CAST, 180 plus is in this quadrant where sine is a negative, you see. So negative sine negative sine 40, this is going to give you negative P. That's 2 mark question, so not bad at all. 5.1.2, what does 5.1.2 say there? 5.1.2 says the following: cos squared 50, right? We need to work this out. So cos squared 50, fortunately, just by looking at our graph, cos is adjacent over hypotenuse. So this is just adjacent of hypotenuse, adjacent of hypotenuse, and then squared. So this is just P squared. Very easy marks. And you can see the marks just flow once you at least have your diagram and also this. So cos negative 80, this is the same as cos 80, right, which is fortunately the same as cos 2 times 40. The reason I've put it like this is so that we can use double angles, you see. So this cos, we can use this formula. Cos 2x is equal to, you can use whichever version you want. Let's use 1 minus 2 sine squared x. So you can say therefore cos times 2 times 40, excuse me, cos 2 times 40 over here, this is going to be 1 minus 2 sine squared 40. And then what you know is that sine 40 is a P, so this is 1 minus 2 with P squared. because the sine 40 is p and then it's squared. And then that's your answer, y minus 2p squared. You see, that's what cos 80 is. Cos negative 180 or cos 80, or there you go. You see, here, it's equal to that, it's equal to that. This you need to know because remember, with cos alpha is always equal to cos negative alpha. It's all the same. Moving on with our question. We now have 5.2 to deal with. 5.2, and as I'm recording 5.2, as of this recording, I haven't even figured out 5.1 yet. 5.2.1. I haven't figured out 5.2.1. I keep making mistakes, but I can do 5.2.2 first and then always come back to it later. So I would say the way I also go through these papers, right? That's how you can do it in the exam. You're not forced to go through this paper in, you know, ascending order or whatever. You can always just make sure you leave enough space for what you need to do. Speaking of which, let me leave enough space for 5.2.1. So 5.2.2, I should do it here. It says here, for which values of x in the interval negative 180 to positive 180 will the identity be undefined? So you can use either one of these two expressions to give answers. So the first thing is 10. We know that it has an asymptote at 90. So you see, for this thing to be undefined, x will be equal to 90, because at 90 we know that the 10 graph has an asymptote. So the graph of 10 cannot have an x that is equal to 90 over there. Secondly, we have an expression this side where the denominator is cos x. The denominator here cannot be equal to 0. So the expression will be undefined where cos x will be equal to 0. So let's work out where cos x is equal to 0. Cos x is equal to 0 where, let's see, cos shift 0. You can either do this in the calculator or you can even just draw a quick cos graph. This is from 0 to 360. If you do it the other way, this would be from 0 to negative 360. Now here is in the middle, negative 180. Here is also in the middle, positive 180. So you're looking at the picture from here, going all the way up until here. So between negative 180 and positive 180, you're asking where will this be equal to 0? So it's equal to 0 at negative 90 and also at positive 90. Okay, so here we can also say x is equal to negative 90. That's one of our answers, you see, because if you put here cos negative 90, see, it's going to give you 0. So that's one of our answers that are within the domain that they have asked us. That's one of the answers. So for 3 marks, you may be thinking, is there like a third answer somewhere? And yeah, I am thinking to myself, is there a third answer somewhere? And the way this looks, most probably not. You know, most probably not, because for these types of questions, you'd be wanting to find cases in the expression where if you put a specific x value, the expression would be undefined. So we thought of positive 90 there, and we thought of negative 90 over there. You see. However, yeah, let's not overthink it. So you'll be asking, where would the 3 marks come from? Let's say at least 2 marks for working out, and then this is a given because of 10. If there's a third one, we can always find that in the official memo fortunately. But let's do 5.3 now. 5.3.1. It's a 6-mark question. It says, okay, well, let me see. It says, without using a calculator, simplify the expression given above to a single trigonometric term in terms of cos 2x. If you're going to simplify this trigonometric expression, this doesn't look like a difficult question at all. Cos squared x minus 1. I should get a better pen, because honestly the way this pen writes, it's kind of boring. Let's see. Sine 150, you can, if you're going to do it in, the trigonometry, or if you're going to use the reduction formula, you can write this as 180 minus 30, right, over 2. And then this is going to give you, in the cast diagram, sine is 180 minus is in this quadrant, and sine is a positive there. So this is going to give you sine 30 plus cos squared x minus 1 over 2. Right? And then, what now? Well, sine 30 is a half. So a half minus 1 is negative a half. So this is negative a half cos squared x. Oopsie. Oh, let's read this better. Negative a half plus cos squared x. So if you're going to put this over 2, what do you have there? Well, you can put each individual number over 2. So you're going to get the negative a half over 2 cos squared x over 2. So negative a half divided by 2, calculator here, divided by 2, it's just going to give you negative a quarter plus a half cos squared x. So at this point, since you're trying to end up with a double angle of cos, you need to think to yourself, okay, fine, cos 2x, right? Cos 2x, we know it is equal to 1 minus 2 sine squared x. It is also equal to 2 cos squared x minus 1. It's also equal to cos squared x minus sine squared x, like that. So all this that we know, right, we need to think to ourselves, okay, to get a 2 here, right, because we need at least 2 cos squared x here, and to get a 1 there. Fortunately, if you take out a negative, if you take out a quarter, right, you're going to have your negative 1. And then, since you took out a quarter, you need to ask yourself, a quarter times what gives you a half? Fortunately, a quarter times 2. See, and then you can swap these around. So you're going to have here a quarter, 2 cos squared x minus 1. And then this is just a quarter with cos 2x. There you go. Very doable question. Now, moving on to the rest of question 5, we have 5.3.2 here. It says hence determine the general solution of this expression. So fortunately, where you see this left hand side, you can just replace it with a quarter cos 2x. So you need to get the general solution of this expression. You see? So getting the general solution of that expression in particular, it's not going to be too bad, because you can start off by dividing both sides by a quarter. Because getting the general solution, it's another way of almost solving for x. You know, low key. It's going to give you 1 over 100. Is it? Yes, it is. Yes, it is. Why am I even checking with the calculator? I guess maybe to appease certain people. Who are those certain people? I don't know. Ooh, I just got schooled, because when you divide, you flip and multiply. Wow, if it was just divided by 4, then it would have been 100. But anyways, there you see the beauty of using a calculator. It helps you to avoid dumb mistakes, you know, like very dumb mistakes. So from here, we can ask ourselves, we're dealing with cos, and our cos is a positive, right? So cos is a positive in this quadrant. I mean, this quadrant here in the first one. So you can start with quadrant number 1, and then we'll do quadrant number 2 over here. Quadrant number 1 and quadrant number 4. But then before we do that, we need a reference angle. Our reference angle, we get it from saying shift cos 4 over 25. Let's get our reference angle. Shift cos 4 over 25. That's going to be 80.79. Now that you have a reference angle, you can carry on. So carrying on from here, you're going to have, in the first quadrant, you take things as they are, right? 2x, let's go to the reference angle, plus k360, k the element of integers. Okay, and then you're going to have here divide by 2 throughout. This will give you x is equal to 40.40 if you round off, plus k180, since you divided by 2, k the element of integers. In the fourth quadrant, let's get more space here. You would say 2x is equal to 360 minus 360 degrees minus the reference angle, plus k 360, k the element of integers. This is like 360 minus 180.79. This is 279.21 plus k 360, k the element of integers. Then divide by 2 throughout. And have x is equal to 139.61 plus k180, k is the element of integers. There you go. Easy peasy lemon squeezy. Yeah, actually no, that was not easy peasy. That's the first. I won't lie, the other questions were easy, but 4.6 and part of 5, yeah, not very friendly. But let's move on to question number 6. Carrying on to question number 6. I'm thinking to myself, I'm out of paper. And you'd be thinking, why didn't you just make sure you had enough paper before you started recording? Why are you being so irresponsible, you guys? Well, you're gonna have to forgive me. The way I'm going through this exam pad, it's not as organized as you would wish, huh? But it's alright. We will make things right when the time comes. Question number 6 says the following. It says, in the diagram, the graphs of f and g are drawn for the interval negative 180 to positive 180. And then he says that the graphs intersect at n over there and at p and at q. This is a question the way it looks, it's so memorable. Like, I can certainly say I've gone through a question like this before. Maybe not identical, but a good 95% resemblance. P here is also a point. P is also a turning point of both graphs. Fine. 6.1 going onwards. So let me just make sure here we know what we're going through. We're going through May, June 2024, Yeah. Here, paper 2. We're starting off with question 6 here. The other ones we did already. And this is, I feel very behind with this paper because I'm taking way too much time with these questions. The first question is asking us for the period. The period, you have a formula. The period will always be, if it's a sine or a cos graph, the period is always 360 divided by the frequency, you see. And these kinds of formulas, these kinds of equations, these are things that you will learn on the course website. You see, courses.bright young brains.co.za. There you go. So with this being said, let's get the period. Frequency, you need to know what the frequency is. And you get that from the equation of your graphs. Your frequency is always the number directly next to your x here. So in front of x, it's a 1, you see. So the frequency is just a 1. So here we have 360 divided by 1. Means that our period is equal to 360 degrees. That's the period of f. Very simple. If the frequency was a 2, you'd say 360 divided by 2. Then you'd get your answer. So let's carry on. Let's carry on. It says write down the amplitude of G. Amplitude of G. G is this graph here, you see. And amplitude also has a formula, which we can easily work out. Now, amplitude is always the maximum y value minus the minimum y value over 2. So here, if you look at the graph of G, the highest y value that it goes to is like a positive 1. The lowest that it goes to is negative 1. That's very clear. So this is 1 plus 1, which is 2 over 2, which is a 1. That's the amplitude. Very easy marks. You shouldn't have an issue with those types of marks. Calculate, write down the value of A. What is the value of A? Up there. You see, so this is f of x is equal to cos x plus A. So it looks like we can just throw in a coordinate that the graph passes through. There, with P. Let's just use that. So the y value is 1, the x value is 45. And then you have, if you're going to solve A, you can say shift cos 1. This is equal to 45 plus A. Shift cos 1 is, let's find out. That's a 0. Okay, very nice. So A here is equal to negative 45. So without overthinking it, our picture is helping us see that the original cos graph would have hit the y-axis at 1. You see, but then, and then this is where you would also have a turning point for your original cos graph. But then since it was moved 45 degrees to the right, you have your turning point over here, as we are clearly seeing. You see, all those basics stuff you need to know. 6.4 says calculate the value of K. Okay. The y coordinate of N and Q. Okay, so you see they're trying to tell us that N and Q are in the same, they have the same y value, which is okay. We can easily see it from the picture also. And how many marks did they offer? They offered 2 marks only, so not bad at all. So we shouldn't take too much time here. They said without the use of a calculator. Wow. Okay, that's that escalated quickly. Well, let's see if we do need a calculator for this type of question, because I don't think we do. So I'm already thinking of using sign the sine graph, because, well, whichever way, we can use any of the two. Let's see. So for the sine graph, let's see, sine 2x, a y value that we're looking for is k. Okay, fine. Well, what we know is that for k, the x value would be negative 75. So 2 times negative 75. This is going to be sine negative 150, which will be sine with the negative. As long as this angle has a negative inside the bracket, the negative can be written outside. You see, and here without using a calculator, you'll be thinking of your reduction formula. So sine 180 minus 30. Okay, if you use the cast diagram, CAST, 180 minus is in this quadrant. 180 minus is in this quadrant. So this negative was originally there, you see. And then this here becomes sine 30, positive sine 30. This is on its own, this was always there. So here you have sine 30 is a half. So the negative is there. Then you have negative half. That's your value of k. Not a difficult question, very easy. 6.5 now. This thing keeps shaking. Like, bruv, we get it. We get it. We get it. We can also close that before I tip it over and the whole thing goes bing-a-ling-a-ling. 6.5 says, calculate the value of calculate the value of x if this equation is equal to this equation. And we are talking about values from negative 45 up until 0. It's a 1 mark question. So let's see here. Calculate the value of x. So this is just saying both graphs were moved 60 degrees left. Both graphs were moved 60 degrees to the left. So they are moving the exact same direction, 60 degrees. So having to have moved them 60 degrees to the left, they're asking where will they meet if you're only considering values between negative 40 and 0. That's very easy because you just look at your picture. If they're going to move everything 60 degrees to the left, and you're only going to now be looking at between 0 and negative 45, the only between 0 and negative 45, if everything moves 60 to the left, this point will also move 60 to the left, meaning they will meet somewhere in here. You see, so 40 minus going 60 to the left, 45 minus 60, they're going to meet somewhere at negative 15. This point here will be somewhere at negative 15, you see. And that's the only point within the interval 0 to negative 45 where the graphs will meet. That's why they made this a 1 mark question. It's very easy. The whole graphs move 60 to the left. This point where they meet will be somewhere over there at negative 15. 6.6, 4 mark question. They said without the use of a calculator, determine the number of solutions the equation this equal to this has in the interval negative 90 to 90. Clearly show your answer. Determine the number of solutions. Okay, so fortunately it's not asking us to work out the actual solutions. They just want us to get the number of solutions. So honestly, in my honest opinion, the one thing I'm already thinking of the moment I saw that question is, let's see what the graphs of f and the graphs of g look like. So g, we have written out the equation, and in f, we're writing out the equation also. So with f and with g, the one thing that I'm thinking to myself is, this could easily be another way of rewriting this whole thing here. Like, I just have a good feeling about it. So what I'm going to do is I'm going to equate these two equations, and then I'm going to see if I can rewrite that expression like this. Because as long as we can do that, we can then use this picture to answer this question. You see? So let's do it. G of x equal to f of x. Even if we maybe don't, we could even just guess that this is exactly the same as f of x equal to g of x. So let's start with g of x. We have sine 2x equal to f of x. It's just cos x minus 45. Looking at this, I'm already thinking of compound angles, you see. So fortunately, I have a formula sheet, and I don't have to worry about cramming the compound angle formulas because they're already here on the formula sheet. So on the formula sheet, the cos compound angles say the following, right? This says cos x with cos 45, and then with the plus sine x, and then sine 45. This is sine 2x. There we go. And then what do you have now? Well, I don't know. No. What do I don't? I do know. We're going to get our special triangle here, the 45, 45 triangle, 45, 45. This is 1, 1, square root of 2. So this is going to give us a cos x with 1 over square root of 2, sine x with 1 over square root of 2. And this is sine 2x. And then you can take out the 1 over square root of 2 as a common factor. You can have cos x plus sine x. Then you can have sine 2x. And then if you divide by 1 over square root of 2 on both sides, this is what you're going to have. Square root of 2 sine 2x. Then this is cos x plus sine x. There you go. And then now you can easily see that they're just trying to ask you the same. They're just trying to say, where does the graph, how many solutions or how many places do the two graphs meet between negative 90 and 90? They meet once and then twice over there. So the answer is just here. You can say therefore 2 solutions. So if you just wrote 2 solutions, maybe you'd have just gotten 1 mark, or maybe 2 if you're lucky. So 2 solutions where f of x and g of x meet between x, the element of negative 90 up until 90. So this is a way of proving that you know what you're doing and you deserve the 4 marks, you know. So let's move on to question number 7. This is the first, after question number 4.6, this is the first smooth question. And yeah, it was not so bad. Let's move on to the next. Let's move on to the next question. Yeah, let's do that. Question number 7. What is question number 7? This is question number 7. Not bad, huh? Well, yeah. Triangles and all that, not bad at all. So let's see what we have to do here. Question number 7 says, in the diagram, ABC is drawn. A, B, and C. AD is drawn such that AD is perpendicular to BC. Then he says, use the diagram above to determine AD in terms of sine B. Okay, so it means we might have to use this angle. Not might, but we probably are. Well, that's not a difficult question because what do we know? Well, sine B. What is sine B? 7.1.1. Okay, do this. 7.1.1. What do we have here? We have sine B. For 2 marks, sine B is equal to opposite, which is AD, over hypotenuse, which is AB. So the only worrying thing about this question is that we don't have AB. We don't have an expression for AB, and it's not looking pretty, but it's all good. Let's maybe try using the sine rule. So this won't work. The sine rule will work because we have a 90-degree angle there. So let's say sine D over, oh no, ah man, not again. It looks like it's gonna be the same thing. We may only be left with no choice but to write it like that. Yeah, let's see, sine D over AB is equal to sine B over AD. And then if you isolate B, sine B, sine 90 is a 1, is it not? Yes, this is just a 1. Well, I might as well remove this, because if you had gone this route, it looks like it's going to be exactly the same thing, which it will be. Man, if you flip both sides, you can have AB over 1 sine B over AD. So they want AD in terms of sine B. So if you want to, no man, from here I could, what am I doing? Like, what am I doing, bruh? Yes, because if you flip this over, this you also have to flip it over. Then if you multiply by sine B on both sides, it's still just just basic trigonometry, which is not very helpful, but based on the information they gave us, this is as best as you can do. Like, honestly, there's nothing else you can do with this kind of equation. Here they said, hence prove that the area of ABC is equal to half BC times AB times sine B. Well, I will just use well, that's very interesting. That's very interesting. Yeah, very interesting, because you would think to yourself, why don't we just use half base times height? Oh no. Well, it's a 1 mark question, so you really don't have to overthink it. You know, you really don't have to overthink it. It's a 1 mark question. So the only thing I'm thinking of is half base, if base is BC, perpendicular height. Yeah, this is perfect. So this is very easy, very awkward but easy. Area of triangle ABC is equal to half multiplied by the base multiplied by the height. So in this case, you already know that AD is this number here. So AD is this expression here, AB sine B. And then this is your base. So let's see. Half base is BC, perpendicular height is AB, sine B. Very easy mark. Okay, 7.2.1. It says, in the diagram, the way this question is worded out, right, it's not very accurate, because if they say determine, use a diagram above to determine AB, AD in terms of sine B. Ideally, they should have given you something for AB, but it's okay. Let's move on. In the diagram, points B, C, and D lie in the same horizontal plane. ADB is equal to the angle ADB and ACB. These two angles are the same. Perfect. So that is fine. And then they say here CDB is theta. And then they say here DC is equal to K. And they say here BD is equal to BC. Yeah. All that being said, they said prove that AD is equal to AC for only 2 marks. Well, this is very dumb because you're just gonna prove that these two triangles are congruent, you see. So you can say here in, let's see here. Let's see. You can say here in triangle ADB and triangle ACB. What you know about those two triangles is that if you're going to prove that two triangles are congruent, just prove that any 3 things are equal, as long as it's not 3 angles. It could even be 3 sides, but don't make it 3 angles. So let's see, between these two triangles, they have 2 angles that are equal. These are both equal to 90. So we can say here ABD is equal to ABC. That's a given. They gave it to you. And then also ADB is equal to ACB. That is also given. And then lastly, so there's an angle here, there's an angle here. And then lastly, we have DB equal to BC. Also given. That's a side. So you can say here, therefore, triangle ADB is congruent to triangle ACB, side angle. 2 angles in the side are equal to each other. So they're congruent. So because they are congruent, you can then say therefore AC is equal to AC is equal to AD. So these are corresponding sides of congruent triangles. Like it's the sides that are on the same part of the 2 different triangles for the 2 triangles. So they are the ones that are equal to each other. You could have also said A and B are equal. Common side, and then you could have said side angle to prove that these are congruent. It's up to you. So 7.2 it's a 3-mark question. This may not be enough space. It says prove that BD is given by this expression. It's just a 3-mark question, so we don't have to overthink it. So it looks like we can use this bottom triangle here. It looks like we can use the cosine rule, because the cosine rule needs us to have 3 sides with at least something. You see, so here we have BD. This we can also label it as BD because they're equal to each other. You see, so we have 2 sides that are already both BD, and then you have another side here, then you have an angle. So in a situation like that, you can use the cos rule. So with the cos rule, wherever your angle is, the opposite side is the one that has to be on its own. So here, I'm going to say BD squared is equal to 1 of any of the sides, 1 of any of the sides, and then here you have minus 2, this times that, and then cos your angle in the middle there. So this, it's something you can get from your formula sheet. You see, if you look nicely at your formula sheet, there's your cosine rule. You see, it's the side that is opposite the angle you have, and then these are any of the other two sides, and then they're also here. So having to have written out a formula, we can just simplify. Simplifying here, we have theta over there. We can just write it as theta. Man, why am I writing so bad? But let's simplify here. Let's see what we're gonna end up with. So here I'm already seeing that there's 2 here. These two are gonna cancel each other out because there's one of each on both sides. Furthermore, here you can have k as a common factor. So you can take out k as a common factor. You can have 1 minus 2 BD cos theta, right? And then you're gonna, since you're trying to isolate BD, you can, do you want to both sides bias? Ah man, what did I do? Oh no, yeah, let's not start off like this. Or can we? Yeah, we can cancel each other out, yes, but then let's put k squared on this side first. It's gonna be a minus. This is equal to negative 2k BD cos theta. Okay, now what? Well, now that k is not going to disappear, let's take out k as a common factor here. If we divide both sides by k, so it's going to be negative k squared divided by k. This is just k equals to negative 2 BD cos theta. Since we were trying to isolate BD, how did I end up here? Yeah, you can just divide both sides by negative 2 cos theta, negative 2 cos theta. Therefore BD is equal to this, cancel out, that's going to be k over 2 cos theta. Not bad at all. 7.2.3 says determine the area of triangle BCD. You need to determine that area in terms of k and a single trigonometric ratio of theta. Well, that's not too bad. It looks like we can also use the sine rule because at least for BD we already have this expression. For DC we already have k, and then we have an angle in the middle. See, that's like textbook area rule question. So the area of triangle BCD is going to be equal to a half multiplied by one side, which is BD, multiplied by another side, which is DC, and then sine the angle, which is D. See? So, or we can say BDC to be specific. Okay. BDC, the angle down there. So if you put x values in there, you can have k here over 2 cos theta, and then DC is what, k over 1, and then sine BDC, that's like sine theta, let's put that over 1. trying to make sure everything is a fraction, you see. So I can just say everything at the top multiplied together, you have k squared sine theta. Everything at the bottom, if you multiply that together, what do you get? You get you'll get okay. So you get 2 times 2 is a 4, and then cos theta. Fortunately, sine of cos is a 10, so this is going to give you k squared over 4 with 10 theta over there. There you go. That's the area of BCD. And it is a single trigonometric expression, and it's in terms of k. Question 7 has been good. Now we are going to question 8. I'm thinking, is the 8, 9, and 10? Or does it end at 9? Oh no, there's 8, 9, and 10. This paper is quite long, eh? And to be honest, yeah, I'm taking way too long on this paper. Like way too long. Way longer than I would have wanted, way longer than I would have expected. But let's move on to question number 8. And let's just finish this paper. Question number 8 is over here. This is what we have. So, what do we have here? Well, we have quite a lot of questions. Whoa. Let's see here. Let's see. Okay, wow, that's too high. But it's all good. No, it was... Question number 8 says the following. It says the following. In the diagram, chords AB, BC, and AC are drawn in the circle with center O. Then they say here DCE is a tangent to the circle at C. So we have to prove the ten-cut theorem here. Prove the theorem that states that the angle between the tangent to a circle, so this is the angle between a tangent to the circle and the chord drawn from the point of contact. So you have a tangent here and then a chord drawn from the point of contact. This is the angle they're talking about. That angle is equal to the angle in the alternate segment. They're saying that angle is equal to that one, and then this angle here is equal to that one. Okay, so proving the ten-cut theorem, this is something I've done plenty times. So what do we have here? 8.2. There you go. No, 8.1, bro. Proving the ten-cut theorem, you're going to say there, this is your circle, right? This is the picture. There you go. This is E, this is C, this is D. This is B, this is A. And O is in the middle over there. So you're going to construct a line that goes through the center of the circle, and it has to be a diameter. So you have to say here, firstly construct diameter. So you have to mention the 3 points it passes through. So we have A, B, C, D, and E. So let's call this F. So you can say construct diameter COF. Okay, that's the first thing you construct. And then you need to construct another line going either to A or B. It's your choice. What I mean is, if you're going to prove that this, depending on which angle you want to use, remember you can use either this angle with that one, or you can use this angle with that one. So if you're using this angle with that one, right, your line, it needs to go to let's see here, give me 2 seconds. Your line, it needs to go to the angle that you're working with. There you go. So if you're working with this angle and this angle, your line has to go to A. If you're working with this angle and this angle, your line has to go to B. So we have constructed COF, and then you also have to construct AF. Okay. So the two laws that you use when you prove the ten-chord theorem, you're going to use the tangent perpendicular law and the law of angles in the same segment. So having to have done this, you have to label your questions. You can label this C1, C2, A1, A2. You see I did it deliberately. The C2, I'm going to make it equal to A2 because they're angles in the same segment, you see. And then the whole of C, like ECF, is a 90-degree angle because of 10 perpendicular radius. And then FAC is also equal to 90 because of angle in a semicircle. So you can state those things first one by one. Let's do the 90-degree angles part first. So we can say here, so let's say here label A1, A2, and C1, C2. So fine, after you've done that, let's write the following. C1 plus C2, we know that this is equal to 90 because 10 perpendicular radius. Okay, and then A1 plus A2 is also equal to 90. Reason is angles in a semicircle. Now that we have identified that they're both equal to 90, we need to state that C2 and A2 are equal. C2 is equal to A2 because they are angles in the same segment. So you're using another law to prove this law. And then from here, since they're both the same, right? Since C2 is equal to A2, you can then write a statement here. Therefore, C1 plus C2 is equal to A1 plus A2. These you have proven that they are the same. So you can say yes, C1 is equal to A1 plus A2 minus C2. Then these cancel each other out because they're equal. Therefore, C1 is equal to A1. You see? And then now you've proven the ten-chord theorem because there's an angle between the tangent and the chord here. It is equal to the angle in the opposite segment, you see. Then here we can say, therefore, BC, this was just, them here, this is just an example. BEC equal to A. You could have also said DC A equal to that one. It's all good. But here we can say therefore BCE is equal to A. You see, because C1 is this, A is that. So this is all good. There is no error here. That should give you your 5 marks. 8.3 or 8.2 rather. I'm just trying to finish this paper before my day starts, you know. If I can do that, that would be great. In the diagram, PQRS is a cyclic quadrilateral. In the diagram, PQRS is a cyclic quadrilateral with RQ equal to RS. RQRS. Fortunately, that's labeled already. They say the ST is a tangent to the circle. Yes. At S. Yes. Is produced to N. Wait, what? No, I have to pause first. ST is a tangent to the circle at S. Then it stops. Then they said SR is produced to N. Then they give you an angle. If you have noticed by now, any Euclidean geometry question that has an angle given, that question is one of the easy ones, and you should always capitalize by getting all your marks. For 2 marks, they said get P. Well, P is equal to N2. The reason is exterior angle of a cyclic quad. They even told you it's a cyclic quad, and you can see it's a cyclic quad. So therefore P is equal to 68 also. Very nice. 8.2.2 Q1. Q1, well, Q1 is the same as S2 because these are equal, so they are interior angles of an isosceles triangle. And what we know is that Q1 and S2, it's interior angles of this exterior angle of this triangle. I promise you, as I'm looking at this question, that's exactly what I'm seeing immediately, you know? And the more questions like these you do, it just gets much easier. So if this is a 68, it means that these two are both going to be equal to 34 because of what we know. So here we can say Q1 is equal to S2. That's where we started. And the reason is base angles of an isosceles triangle. Okay, there we go. And then what do we know? So now you can say N2 is equal to Q1 plus S2. The reason is exterior sum of exterior angle of a triangle. Yo, I feel like I'm writing on a balloon here. The way I'm writing is just so bad. So here you can then say therefore 68 is equal to Q1 plus S2, and then this, they're the same, so you can say 2Q1 is equal to 68, and then if you divide both sides by 2, you're gonna get the 34. Okay, somebody's crying, but I don't know if you can hear that easily. So carrying on, we said here that, let's see, 8.2.3, it says we need to get the value of S1. S1, well, it looks like we can just use the Tenko theorem here because S1 is easily equal to Q1 also because of the Tenko theorem. Wow. Yeah. So S1 is equal to Q1, which is equal to 34. The reason is 10 chord theorem. Yeah, not bad. Fine, moving on. Question number 9. What do we have in question number 9? Question number 9. Oh, come on. Question number 9 says the following. It says in the diagram, AB is the diameter of the circle with center F. And then it says here, AB and CD intersected G. Okay, so usually as you read a question, you want to pause and see what they're talking about. There's a diameter, fine. Center F, already this is a 90-degree angle because it's a line. It's a line that is this is an angle subtended by the diameter of a circle. These lines are all radius lines. Okay, let's see. AB and CD intersected G. AB and CD intersected G, yes. FD and FC are drawn, yes. BA bisects CAD here. Then he says this is 37. So already, as long as you're given an actual angle to work with, makes your life very easy or very, bearable. Determine given reasons any 3 angles equal to D1. So this is very, very doable. So the first one is A2 because they're angles in the same segment. You see, A2 goes to arc BC, and then D1 also goes to arc BC. So that's the first one. D1 is equal to A2, which is also equal to 37. The reason is, or we can just end here actually. D1 is equal to A2. You don't have to worry about this part. Then the reason here is angles in the same segment. Okay, there you go. Now with that being said, so as you find other angles equal to D1, you use those to find more information. Like for example, A2, you know that it is half of F2. Yeah, but how is that even helpful? Oh yes, A2 is equal to C2 because these are radius lines. And I thought of that when I was saying this is half of, when I say this is half of that, I already thought, okay, this is an exterior angle of this triangle. So whatever this is plus that, it has to give you that one. And then it reminded me these are radius lines. So we can say here A2 is equal to F2. Then you can say, yeah, the reason is, no man, not F2, C2. They are base angles of an isosceles triangle. Okay, so here we can say therefore C2 is equal to D1 also. And then now we have how many angles equal? There's two only. We need a third one. So you can think, what is C2 equal to? You can still be using this, and we could still be using the original picture. It doesn't, it's up to you. But normally using other angles is more helpful. So the one thing that I'm thinking of here is that they told us that AB bisects CAD. So if they say AD, if they say bisects CAD. Bisects in maths, it means cut in half, you know. So if A2 is equal to A1, then that's gonna be a third angle equal to D1, you know. So things like that I would not want to overlook and just leave alone, because why not? Why would you want to do that, you know? So let's just carry on and say what we can. So here A1 is equal to A2. It's been given. So therefore A1 is also equal to D1. So 1, 2, 3 angles equal to D1. A2 gave us the others. 9.2. What is 9.2 right there? 9.2, right, says show that DG is equal to GC. Well, that's very not hard. Is it? It's a formal question. Well, these are equal also. What do we have? Well, these are equal. Base angles of an isosceles triangle. So we can maybe use congruency, because these two triangles, they have two angles that are equal. They also have what do they also have? They have two lines that are equal, and they have a common side. So that's what we're going to do to prove that DG is equal to GC. We're going to use congruency. So you need to state which triangles you're working in first. So I can say here in triangle, we're working with triangle CGF. No, you can call it CFG since I wrote F first. So CFG, and then here just to be DFG. DFG. So these two triangles, the first thing is FG is equal to FG. That's a common side. Secondly, we have D2 equal to C1 base angles of an isosceles triangle. Furthermore, we can say here DF is equal to FC, radii. So this is a side, and this is an angle, and this is a side. So you can say here, therefore, triangle CFG and triangle DFG, let's just say, are congruent. I wanted to write the mathematical way. This is what I wanted to write. I wanted to write, therefore, CFG is congruent to triangle DFG. This is what I should have just written out, but here I ended up writing it in notes because I had written this here. But it's fine. It's not a big issue. The reason here is that side angle side. Two sides of an angle, you have shown them to be equal to each other. So with all this being done, we can say, therefore, DG is equal to GC. That's good enough. The corresponding sides of congruent angles, of angles that are of triangles that are congruent. These are corresponding sides of triangles that are congruent. There you go. 9.3 says, if it is further given that the radius of the circle is 20 units, right? Calculate the length of BG. If it is further given that the radius of the circle is 20 units, yes, calculate the length of BG. BG, well, that's not bad because this is 20, this is 20, and this whole line here is going to be a 20. So if we can just work out this small part, we should be good. But normally if we had DC, that may have helped us in a way, but it's a formal question, so it's fine. Let's get what we can get from the information that we have. So we have angles that were given. There's 37 somewhere, there's 37 here and there, so we know what this angle is, and we can work out what that angle is over there, which is the same as this angle over here. Well, okay, if we can work out this angle, we can easily then use trigonometry to work out GF. So let's just get an angle for F2. Let's start there. F2 is equal to A2 plus C2. The reason for that is exterior angle of a triangle. So here we can say F2 is equal to 37 plus 37, which is equal to 74. Yeah. Is it 74? Yes. But guess what? There is your consolation. So now you know that this angle here is equal to 74 degrees. So it means that in this triangle now, this one here, triangle CFG, this is a 90-degree angle because you proved that these are equal to each other, you see. So you can even tell them that you know that, you see. G2 is equal to 90 degrees. The reason is line from center bisects chord. There you go. So this, you know, it's a 20, it's given. Do you want to say it? You can. I mean, to be fully comfortable, I guess you can just throw it in there. So from here you can now use, we want GF, because if you at least get GF, you can then say 20 minus GF, you get BG. So let's get GF. So to get GF, this is going to be adjacent over hypotenuse. So that's going to be cos. So we can say here cos F, it's got adjacent, which is GF, over hypotenuse, which is FC. Putting the values in there. Why am I writing so low? Like so much space and I'm writing so low. Almost to the point where it's not visible. Why you gotta do that? GF is what you're looking for. CF is 20. So if you multiply by 20 on both sides, you're gonna have 20 cos 74 GF. 20 cos 74 5.51. Okay, did they say corrected to decimal places? Didn't say anything like that, but yeah, in a situation like this, I would much rather not round off. But let's see. Therefore, BG. But in a situation like this, I would now be thinking, did I do the right thing? You know, does it look correct? Yeah, it does. It does look fine. It looks fine. It definitely looks fine. Cos adjacent over hypotenuse here. Everything looks fine. I just shouldn't be thrown off by that decimal there, because that's what we have, you know. So here you can easily then just say 20 minus the answer. You have 14.49. There you go. 14.49. That's the length of BG. Okay, question number 9 was okay. It was friendly, not bad at all. Let's move on to the next question, which is question number 10. So, just a disclaimer for question number 10. Question number 10.5, yeah, I may have to figure that out later. But for now, let's do the rest. Question 10, what does question 10 say for us here? Do I want to write here? Yeah, it's okay. Let's not waste paper since we're already out of paper. 10.1. Okay, we have a very interesting diagram. I've already gone through this question paper, or like this question rather. So all these questions are not going to be very difficult to work out. Excuse me. It says prove with reasons that, okay, no, description first. In the diagram, COD is the diameter, yes, of the circle with center O, yes. Then it says here EA is the tangent to the circle, yes, at F. Then it says here OA is perpendicular to CE, which is the diameter. Then it says here, the diameter is COD rather. It says the diameter COD produced intersects the tangent at E. OB produced intersects the tangent at, OB intersects the tangent at A. Then it says here CF intersects OB at T. And then they said, these are the lines are drawn. So this sketch is quite messy, to say the least, you know, but this is a 90-degree angle. Wow, I didn't notice that. Angle subtended by the diameter of a circle. This is also 90 degrees. Angle subtended by the diameter, of a circle. So that's interesting. all this information, yeah, it's quite a lot. It's a lot of information. But let's see, the first question is asking us to prove that TODF is a cyclic quadrilateral. Well, fortunately, this is going to help us, this and that. O1 is equal to 90, given 90 degrees. DFT. DFT is also equal to 90 degrees. That's also given. And then here we can say, therefore, O1 is equal to DFT. That has been proven. So you have proven it. So because you have proven that this angle is equal to this angle, now you can say, therefore, TODF is a cyclic quad because an exterior angle is equal to the opposite interior angle. As simple as that. You have found an exterior angle somewhere, boom, that is equal to the opposite interior angle. That's all you need. Let's move on to the next question. Wow, wasted paper here. But let me not waste more paper than I already have wasted. So let's just start here. 10.2 says you need to prove that D3 is equal to T1. D3 equal to T1. Well, fortunately, D3 is equal to T3 because exterior angle of cyclic quadrilateral is equal to the opposite interior one, and then T3 is equal to T1. Very straightforward. So start there. D3 is equal to T3. Reason is exterior angle of cyclic quad. So if you don't know the laws of a cyclic quad, then this question is going to be a problem for you. Then here we can say T1 is equal to T3, vertical opposites. So with that being said, we can say therefore D3 is equal to T1. See, proven without a shadow of doubt. 10.3 says prove that these triangles are similar. TFO. TFO. Prove that it is similar to DF. So it's the small one there, the small one here. So fortunately with TFO and DFE, we already know that D3 is equal to T3. That's been proven already. So we can say in triangle TFO and triangle DFE. So normally 99% of the time the angles match. So the D will be equal to the T, the F will be equal to the F, and then the O will be equal to the E. So let's start off with the D. So we know that D3 here, D3, which is the angle there, right? It is equal to T3. That's, we can just say again, exterior angle of a cyclic quad. So we have identified that this D is equal to this T. Now you can see here, because the O is here where the E is, ideally the O there is the one equal to the E there. And then the F here is the one equal to the F2 there. F4, F2. So how are we going to give that as an answer? Well, I'm thinking of things like the 10-chord theorem here. You know, I'm thinking of things like the 10-chord theorem, because when you're going to work out angles that are equal to each other, you need to find something that they are both equal to. You see, you would find something that they are both equal to. So let me see here. Yeah, I should have just worked on the other page, because this now is a big distraction. But it's okay. So here we can say that F4 is equal to C2, and then F2 is also equal to C2. So because they're both equal to C2, they're equal to each other. F4 is equal to C2 because that's the 10-chord theorem. F2 is equal to C2 because they are radii. I mean, because they are base angles of an isosceles triangle. So let's state all that information. We can even start off by saying OC is equal to OF, that's radii. That's your reason over there. And then we can say here, therefore, C2 is equal to F2, base angles of an isosceles triangle. So you've identified that F2 is equal to C2. Then now you can say F4 is also equal to C2. The reason is 10-chord theorem. Because you have an angle between the tangent and the chord, that angle is equal to the angle in the opposite segment. You see this line here and that line there. It's subtended by this chord. So you can say therefore F2 is equal to F4. That's not part of the question. So because F2 is equal to F4, and also because D3 is equal to T3, you have two pairs of sides that are equal to each other in these two triangles. So the third ones, which is E and O2, you can say E is equal to O2. The reason is interior, or rather sum of interior angles of a triangle. There is your answer. Then you can say therefore triangle TFO is similar to triangle DFE. The reason is angle, angle, angle. You have proven that three angles are equal to each other. Then 10.4 says if B2 is equal to E, where is B2? B2 down there, the tiny angle there, it's also equal to E. You can hear my stomach grumbling. Angle. B2 is equal to the E here. Fine. Prove that DB is parallel to EA. That's very, very easy. That's as easy as they get right there. But anyways, so what can we do? What can we do? So this, they say these are equal. They have given us, and it's a 2-mark question only. You see, it's a 2-mark question only. So if you're going to prove that lines are parallel, you need to show that two angles are equal to each other using other laws. Fortunately, since you're going to want to show that E is equal to D, you can start off by saying, since you want to show that E is equal to D1, you can start off by showing that D1 is equal to B2, because these are base angles of an isosceles triangle. Very, very direct and straightforward question. So here you can say, you can even start off by saying OB is equal to OD, radii. It doesn't get old. Then you can say here B2 is equal to D1, base angles of an isosceles triangle. And then lastly, you can then say therefore D1 is equal to, let's just start off by saying B2 here is equal to E. This is a given, you see. So yeah, because they are now both equal to B1, you can say therefore D1 is equal to E. See, you've written it out. This is equal to B2, this is equal to B2, so they're equal to each other. And then, so because now you've proven that this angle is equal to that angle, you can say therefore DB is parallel to EA because corresponding angles D1 and E are equal. There you go. That's that's how you do it. So that's all good, nothing crazy, nothing major.